Okay, so part 1 says to find in terms of k the x-coordinate of that stationary point of the graph. So here's the function, I've written it out. Now we want the derivative of this. The derivative of e to the power of negative kx is the same, but then multiplied by the derivative of e to the negative kx, which is simply negative k, and the derivative of 3x is simply 3. And we want this to equal 0 because it's a stationary point. And you're almost there. You've got yourself halfway. So you've earned 1 mark already. Now we've just got to get x on its own. So we'll take k e to the negative kx across to be positive. We'll take the k across to be 3 over k. And now we'll convert this into the natural log, or the log to base e of 3 over k equals negative kx. And finally take k across, and we've got our x in terms of k. So therefore x equals negative 1 over k, the natural log of e, 3 over k. And that will do. That's worth 2 marks. That's A part 1. Alright, so let's now look at part B. State the values of k such that this x-coordinate is a positive number. Now, let's just look at our x-coordinate. At the moment, simply because, if you recall, k is a positive number, so this fraction here, negative 1 over k, is a negative, and we want x to be positive, and we've got a negative in that factor. We need a negative value for log. This needs to be negative as well. So we've got a negative number. If that's negative, then we will have a positive number. So we want, therefore, log to base e of 3 over k has to be less than 0. Now I'm going to just use the graph of this to show you what I'm talking about. That crosses at 1. Let this be the log of 3 over k. Therefore, this is 3 over k, the x-axis is 3 over k. It's negative between 0 and 1. So when 3 over k is between 0 and 1, that value is a negative. It's underneath the x-axis. When x is greater than 1, or when 3 over k is greater than 1, then it's above the x-axis. For this to be between 0 and 1, we need a bigger denominator underneath. Therefore, k has got to be greater than 3. Okay, and there's 1 mark for A part 1, A part 2, sorry. Alright, let's look at part B. What is part B? Part B says for a particular value of k, the tangent of our function at x equals negative 8, this should be x equals negative 8, passes through the origin. What's that value of k? Alright, well, we have some sort of a function. Let me just do that one again. We have some sort of a function. Now, when x is negative 8, the tangent to that curve there will pass through the origin. So, we need a y value. We know x is 8. We need our y value. That's the function of negative 8. And we need a gradient, which is the derivative of negative 8. Once we know that, we can put it into y equals mx plus c. Now, c is 0 because it goes through the origin. So we know that's going to be plus 0. Alright, let's find the gradient at negative 8. We've already done that. If you remember from part 1, the gradient was, I'll just scroll down, the gradient is this one here, negative k e to the negative kx. That's the gradient, that's the derivative. So I'll just replicate that. The function of negative 8 is negative k e to the negative k times x, which is negative 8, plus 3. Okay, that's the derivative. That, by the way, is negative k e to the 8k plus 3. Alright, let me check that. That'll do. Now, we know x is negative 8. We now know the gradient. That's the gradient. And now we know the x, we know the gradient. All we need to know is the function of 8, this one here. The function of 8 is substitute 8 into the original equation. And the original equation was e to the kx, this is negative 8 by the way, e to the kx plus 3x. Alright, so that would be e to the, oh it's negative kx, sorry, negative k times negative 8 e to the 8k minus 24. Alright, so we know now what y equals, we know what x, m equals, we know what x is. So let's try to squeeze that in, or actually let me scroll down, change the color, and let's scroll down and substitute y equals mx plus c. The y value is this one, so e to the 8k minus 24. M was this one, negative k e to the 8k plus 3. X is negative 8, so times negative 8, and c is 0. Now solve this. E to the 8k minus 24 equals 8k e to the 8k minus 24. And I'm just going to cancel the minus 24s and bring everything to one side. So 0 equals 8k e to the 8k minus e to the 8k. Therefore, e to the 8k is common, leaves 8k minus 1. Now, e to the 8k cannot equal 0, but this can equal 0. Therefore, 8k minus 1 equals 0. Therefore, k equals 1/8. And that's for 2 marks. How'd you go? All right. Until I talk to you again, stay happy.